All right, boys and girls, here's our last unit, our last part we're going to talk about with stoichiometry. It's called actual yield and theoretical yield to calculate the percent yield. So, first couple things you need to know before you do this. The difference between theoretical and actual yield. The theoretical is what you calculate, and where the actual yield is what you really got in a lab. So, the actual actually produced. Because not all reactions are going to produce the exact amount that they should. There's always other factors that come into play. For example, like you could have spilled something. You could have not measured right. You could have dirty glassware, things like that. So why won't you always get 100% yield? I just told you. All right. Outside factors come into play. Spilled something, dirty glassware, didn't measure exactly correctly. Maybe let the reaction go too long, maybe didn't let it go long enough. Things like that happen. All right, so even though you should get close to 100% yield, you're not always going to get 100% yield. All right, that's pretty unlikely. But if you do, awesome, good job. All right, so what's the formula for the percent yield? Well, the formula for percent yield is actual over your theoretical times 100. All right, and that'll give you your percent yield. So actual over theoretical, so in other words, what you actually produced, and basically the other thing is what you should have produced. All right, so applying this formula should go pretty smooth. So here's the easy example, and there's more involved examples than some. So determine the percent yield. So you have 68.3 grams of ethyl acetate should have been produced. So should have been, that means that's your theoretical, but only 43.9% is recovered. So this is your actual. So how do we do this? Actual over theoretical times 100. And that'll be my percent yield. All right, so we go 43.9 divided by 68.3. So times 100, you get a 64.3% yield. Now, is that good? Not really. No, that's not too good. You generally want to be in the 90s, okay, for percent yield. All right, so actual over theoretical times 100, that's your percent yield. So this is my percent yield of this particular case. Now, let's take this and apply it to the calculations we've done before. So here's a more difficult example. Let's say we have this reaction. It says, what's the theoretical yield? And produce that bugger out. So if you read this out, here's my chemical reaction. The question is it balanced? And let's see. It is balanced. Nice, it's already balanced for us. So we don't have to worry about balancing it. Now it says, what's the theoretical yield if 24.8 grams of CaCO3 is heated to 513.1 grams of CO? All right, so I don't know what this is. It must be a typo. Sorry, heated to 13.1 grams. All right, so the first thing we got to do is we got to use a little stoichiometry to figure out how much we should have produced. So this is what we actually produced, the 13.1 grams. We got to figure out how much this should have produced. In other words, we got to calculate our theoretical yield. So use our given. So we got 24.8 grams of CaCO3. So we go grams to moles, so grams of CaCO3 to moles of CaCO3. So it's always equal to 1 mole. So using our strategy guide, let's see, where's it at? So using our strategy guide, we're from grams to grams. Step, step, step. So just follow the steps and you should be good. So what is the weight of calcium carbonate on the periodic table? Let's see, calcium weighs a whopping 40.078. Whoops. 40.078. Then we add carbon plus 12.011. Then we add 3 oxygens. So plus 15.999 plus 15.999 plus 15.999. All right, and we should get about 100.0 0.086. At least that's what I got. All right. And now our next step would be mole to mole ratio. So mole to mole ratio from this compound to this compound. So we look from here to here. It's a 1-to-1 ratio. So really no calculations necessary. It's moles. This is moles of CaO. So really no calculation necessary because it's a 1-to-1 ratio. And our last step, we got to go from grams of CaO from moles of CaO. So we know 1 mole. So what's CaO? Say 40.078 plus 15.999 gives me 56.077. All right, now we have it all set up, calculate it out. So let's see, we go 24.8 divided by 100.086, enter, times 56.077, and we get 13.89514, so on and so forth. So how many sig figs do we go to? Well, this one has 3, so this one goes to 3, so it's going to be 13.9 grams of CaO. All right, so we compare that. So this is our theoretical yield, the one we calculated, compared to the actual, which is 13.1, over 13.9 times it by 100. So we go 13.1 divided by 13.9 times it by 100, and you should get 94.2% yield of CaO. Whoops. There we go. There. Now that's a pretty good yield. That's what you want to get. You want to get in the 90s. All right. But notice how these can get complex. So this is real simple. They just give you the stuff, and you just got to punch into the actual divided by theoretical. Whereas this one, you have to figure out the theoretical using stoichiometry and using that stoichiometry strategy wheel, and then plug it into the percent yield problem. And once you get that, you should get that. That should be good. And we'll do plenty of examples in class. So hopefully this helps you out. We'll talk to you later. Have a good one. Take care.